Well, I have noon up on my computer, so I'm going to take this opportunity to introduce myself. This is Steve Larson, excuse me, the staff at Hoard's Dairyman here. We welcome all of you. We have a nice bunch of you out there with us today, real time, pardon me, so to speak. So we, without any further delay, I want to turn this webinar over to Mike Hutchins, and we're looking forward to learning about new milk analyses and how we can use them. And we want to thank QLF for their sponsorship, and then we'll let Mike Hutchins take it from there.
Well, Steve, thanks very much. It is my professional and personal honor, to be honest, to introduce our webinar leader today, Dr. David Barbano. David is professor of food science at Cornell University and also director of the Northeast Dairy Food Research Center. Dr. Barbano received all his degrees from Cornell, grew up in Casanova, New York, which is in Madison County, for those of you that know your New York state geography as far as that goes. Dr. Barbano conducts applied and basic research in dairy product manufacturing and milk analysis for dairy herd management. And that is their theme, as you'll see from there. He's received a number of wonderful awards from various organizations, including several from the American Dairy Science Association. And it was my privilege to be on the board with Dave when he was president of the American Dairy Science Association here just a few years ago. And his question is, what's the best part of his job? And he says, working with students to create new knowledge, technology, and science-based solutions to problem in the dairy industry. So, David, we're very pleased to have you on board today, and we will turn the program over to you to address your title up here, Fine-Tuning Herd Care with New Milk Analysis. Welcome, Dr. David Barbano.
Hey, thanks, Mike. It's a pleasure to be here, and I thank Hoard's Dairyman for the invitation, the opportunity to do this presentation. The first, here we go. We got the first slide. We got the second slide before I'm ready for it. Let's go back right there. Before I get started, just want to recognize some of my colleagues. The work that we've done for the last 4 to 5 years that's got us to where we are today has been a real team effort. And the folks at Minor Institute, Heather Dan, Rick Grant, my colleague Katerina Maylili, who actually is in Italy but works part-time for me, are really all part of this, and a lot of students and colleagues in animal science at Cornell also. So it's a real team effort, and I'm kind of representing the team today. In terms of the topics I'd like to address today, I'd like to kind of think about, and this is where I started, of what dairy farmers need for farm management. And particularly for a guy from food science, asking a question like this that didn't come up through the animal science side, maybe it's a little different perspective on that. Review of herd level milk fatty acid analysis and interpretation, kind of bringing up to speed on what we've done in the field and some of the things that we've seen that have led us down this path of recognizing the value of some new metrics that we've produced in terms of milk analysis. Present today some new data, herd level data, and some individual cow level data that we have that's really kind of fresh off the machines. We're going to talk about the relationship, seasonality of fat and protein, and its relationship to milk fatty acid composition. And these new metrics kind of give us a new window into understanding what's going on in the interaction between cows, health, feeding, management, and so on, that I don't think we see from just looking at the fat and protein content. We'll talk about stage lactation impact on milk fatty acid composition, and this is really a very important backdrop in terms of understanding that all this is going on underneath the surface of the bulk tank in terms of stage lactation, and particularly the most important message here is this technology in milk analysis starts to mature and we apply it to either individual cows or feeding groups. We have to really be careful because there's very systematic stage of lactation effects that we've got to consider in interpreting the data. And then I'm going to share with you data that we've gotten in the last year from a survey, milk analysis survey, and some management information from about 170 farms from all over the United States with a wide range of production level, all kinds of differences in management and feeding, to look at whether the fundamental relationships really kind of apply outside the Northeast U.S. We'll talk a little bit about future directions in terms of what we're doing. What do dairy farmers need? They need analytical results that will help them manage the efficiency of feed utilization, metabolic health during the transition period, mammary infection, do a better job with animal welfare and demonstrate that we're doing that through analytical results, mitigate environmental impacts, and really try to do things to improve the reproduction and economic and performance and sustainability of dairy farms. Ultimately, the success of farm management depends on the correct decisions down to an animal by animal basis. And the challenge really is to find, and particularly in large farm management, the cow of interest that needs something special right now, make a decision and take the correct action. So in the end, milk production, really, I look at it from the food science side and from a factory where I'm receiving a tanker load of milk. What's in that tanker is the sum of the performance of all the individual cows. Everybody had their contribution. What's important is that we make a lot of data really fast with this, and you get overwhelmed by the data. We really need to condense it down to the information that helps us make decisions and not be buried in a sea of numbers. How can today's new technology be better harnessed to manage each individual cow? Cow really needs to be a cow of interest, and we have to figure out how to apply this technology to be able to respond to the needs of groups of cows, but right down to when we get to health and reproduction, individual cow information. So we add on the interest research. This last couple of months, we've completed a study of about 170 farms from all over the U.S. We have instruments now using bulk milk for novo mixed preformed fatty acids, chain length of fatty acids, and unsaturation at the St. Albans Cooperative in St. Albans, Vermont. There's 400 plus farms in that cooperative, and we've been doing this for the last 5 years on almost every pickup of their milk. This data has been reported directly to the farms along with their other test results every day. Agrimark Cooperative is doing the same now for about 1,200 producers in their cooperative in the Northeast, and Cuga Marketing. They each have an instrument up and running doing this testing and providing data back to their producers. We've also enabled the Stearns County DHI and the Zumbrota DHI labs in Minnesota. There's 4 instruments now active and running there, and they're taking samples, both bulk tank and individual cow samples, to do this testing. We have the instruments at Cornell, Minor, and the Texas Federal Milk Market. So as we're going with this, we're getting more and more data on bulk. And then for individual cows, the DHI labs in Minnesota are up and running. I hope to have another DHI lab further west running in February of this coming year. And at Cornell and Minor Institute, we've got individual cow testing, particularly at Minor Institute, where we're developing lactation curves and a lot of detailed information in terms of how these parameters behave in terms of individual cows. So we're getting much better understanding how to use the milk fatty acid data for whole herd management and for milking group diagnostics. We're really not kind of ready for the full individual cow type approach, but when we do that, one of the challenges is going to be you really need to have high frequency data. And I think where we're going with this is we really need to develop hardware and software to integrate this milk testing approach into the milking system so that we get data on a continuous basis from every cow. That's kind of the longer term vision, but that's where really we start to be able to make decisions and have information turnaround. No, there wouldn't be a technician in a white coat on the farm. This would be a sensor in line, and it would be shooting off a fingerprint of the milk from each cow, and it would go to the cloud, and you'd get back a list of cow numbers or groups and things you need to do. That's kind of the vision. If we look at the tank milk testing and where we started in this, the first thing that kind of came to light when we started this about 5 years ago at the St. Albans Co-op is that we saw a fairly strong correlation of the what are called de novo fatty acids with bulk tank fat test, and traced it back that it seemed to be telling us something about how well the cows were digesting forage and utilizing forage in the diet. So I'm going to explain a little background on this to kind of bring everybody up to speed, because this testing and some of the jargon is a bit new on the milk side. I know you animal science folks have so many acronyms, and it's like alphabet soup on the feed side in terms of NDF and ADF and all that. Well, we're going to have some new things over on the milk side now. When we get down to it in terms of the fat content of milk, 99% of the fat in milk is in structures called triglycerides. There's a glycerol backbone and 3 individual fatty acids attached to it. Those fatty acids vary in carbon number. Each one of these points would be a different carbon as we go down the chain. So the chains vary in length, and then there could be a double bond or an unsaturation in a chain, and that could vary in the fatty acids. And what this new technology is doing is actually measuring the characteristics of this portion of the molecules and telling us what proportion we have of different chain lengths and degree of unsaturation. That's kind of the new thing. This is not a total fat test. This is breaking that fat test down into what's making it up. When we talk about de novo, mixed, and preformed fatty acids, we've basically got 2 circles. The de novo, that means made within the secretory cells, are the fatty acids from 4 carbons. So C4 is a 4 carbon, C16 is a 16 carbon. After the colon, the 0 means it has no double bonds. If it has 1, there's 1 double bond, 2 is 2 double bonds. So from 4 carbons up to 16 can be made de novo or within the secretory cells from low molecular weight substrate. The VFAs that are produced in the rumen fermentation of forage are carried through the bloodstream, and they become the substrate, the material that we build from scratch in each mammary cell, these fatty acids. The preformed is the other group, and those are ones that are already in the feed. They're fully made, 16, 18 carbon and longer, and those the cow consumes in the diet. They're present in body fat, and we'll talk about how they get handled. But what you notice is the 2 circles overlap. So analytically, what we created was a way to run the machine that does your fat protein test, but at the same time, get more information out of the same analysis, where we tell you the proportion of the fatty acids that are de novo, the proportion of the fatty acids that are preformed, and the proportion that are mixed, and how the balance of these changes in terms of de novo going up and down, preformed going up and down, tells me something about how the cow is reacting to the diet or management or environmental conditions. And this is kind of a what we feel a very useful new piece of information that helps give more richness to trying to make a decision. My fat test went down. What's happening here? Why did it happen, and what caused it? Or if it went up, the same question, only I want to do more of that. So here, in terms of novo fatty acid synthesis, how consumes feed, goes to the rumen. We have the rumen fermentation, and 2 key compounds, volatile fatty acids, VFAs, that are produced are acetate and butyrate. There's also propionate being produced from that fermentation, but acetate and butyrate are the two that are carried through the bloodstream and really fuel the de novo synthesis of milk fat. So these are really good end products of the fermentation that we use to make more milk fat. We talk about preformed fatty acids. The cow eats feed, the dietary fat, the palmitic 16-0, stearic 18-0, all the other longer chain fatty acids go in from the diet, can be carried by little carriers in the bloodstream that bring them to the mammary tissue. We can have fatty acids preformed coming from the liver. And in a transition cow, we're mobilizing adipose tissue or body fat in the form of NEFA, non-esterified fatty acids. And those are being carried to the mammary gland too. And they will build the preformed fatty acid portion of the milk fat. So there's these two things going on simultaneously, and how the balance, there should be a shift in the balance of these that's normal for a healthy cow over stage of lactation. But what the new metrics will do is to let us know whether she's on track or whether she's going in the wrong direction here, and why did that happen. So in terms of infrared milk analysis, this is mid-infrared, not near. Near is the thing commonly used for feed analysis. Mid, it's a different range of wavelengths, is what's used for milk. And at St. Albans Co-op, we started out with a manual machine. This is the model. It's produced by Delta Instruments. And we created statistical models to extract information out of the spectra, or the fingerprint of the milk, to measure de novo mixed and preformed fatty acids and chain length and unsaturation. This instrument will handle about 50 to 70 samples per hour. It gives you all the milk components, the NPN, urea, that's the MUN, all the fatty acid parameters, and it goes all the way up to a bigger, faster machine that can do 600 samples per hour. This is a direct measurement on milk. There's no chemicals involved. The milk goes through the machine, and we get answers. So this is kind of the overview of the testing technology and the new things we've developed. I know Mike is really anxious with his polling questions, so I think we're ready to go. First question.
Well, here's our first polling question. Get ready to vote. This should be pretty fast, Steve. You got to get there. Get ready. Is there any correlation between the individual fatty acid groups and the bulk tank fat percent? So you have one of two choices here. It's either pretty black or white. No, they all go up and down together. Or yes, bulk tank is correlated with specific fatty acid profile. So we're off and running here, and boy, we got lots of votes coming in here, but they're kind of slow here.
Yeah, well, how are you leaning on this one, Mike? I think I might take the second choice, the yes. But,
yeah, I think I'm going to go with second choice as well. And we've got about almost 2/3 the vote in. So let's go ahead and close the polls, Jim, and we're going to share this. And Dr. Barbino, what do you think of the answers or the voting here today?
Well, I think some of the people must have been looking at some of the stuff we've been talking about for the last couple of years as a really good sign. Yes, the change in fat test is definitely correlated with specific fatty acid profile, and really that's what we've been trying to figure out. So how does that happen, and what things do I need to do to get the profile to do the right stuff so that I get a higher fat? Here's the data that we've gotten out in the beginning at St. Albans Co-op that alerted us to this. When we were just analyzing all the milk from the co-op, we started to see this relationship that, boy, if you got the de novo fatty acids up, now this is grams per 100 grams of milk, so you say, wow. And this is percent fat over here. Percent fat, what's the units on that? Oh, it's percent. No, it's grams per 100 grams of milk too. So that's what we've always been measuring. And it's just saying a little bit differently here, but this is population data for 430 farms, and our square root of 0.6 is pretty good. This is all the farms, Holsteins. I think there's some Jerseys in here too. We're up at the higher fat content, but this really piqued our interest, and this is where we started to drill down a little deeper. What we know is with those farms that had higher fat content, were they just producing less milk per cow? So what I want to do is review some of the herd level milk fatty acid data and the interpretation. What we did on that 430 farm study is we drilled down deeper, and we did 2 field studies, one in 2014, one in 2015, and this is where Minor Institute and the staff there really kicked in, did a super job. We selected 10 low de novo Jersey farms and 10 high, same thing on the Holstein side, to go out, take feed samples, get farm management information, and most importantly, determine the amount of milk produced per cow when de novo was low and when de novo was high, and what they were doing to make this happen. We did that in 2014 with the Jerseys and the Holstein farms, and then in 2015, we decided based on those results to drill down a little deeper on Holsteins, and we repeated it with a split group of 40 farms of high and low de novo. Into that first year is kind of what we had to go on that really piqued our curiosity. So we've got 10 farms that are low de novo and 10 high. This is the average for a whole year on those farms. The high de novo farms were nearly 4% fat, Holsteins, and 3.6 on the low. They were 0.15 higher. This is de novo in grams. It's relative percent, grams per 100 grams of fatty acids. We started out this way because we didn't know how to interpret the other data. So it seems like a small difference here, but this is pretty good in terms of a year average. What are these farms doing? And are these higher fat farms, higher protein farms, just producing less milk per cow? I'm a cheesemaker at heart. I looked at these Jerseys and said, oh my goodness, 0.9% higher in fat and 0.5% higher in protein. This is huge in terms of cheese yield. So what are they doing? Are these cows just producing less milk, or is this really better productivity? That's where we went out field work, and this is from the study with both the Holsteins and the Jerseys in 2014. What was a surprise to us, now the milk per cow per day is a little lower than what you'd expect for a Holstein herd, but remember, these are half Jerseys in terms of the herds, that there was a real strong trend for the high de novo herds to actually produce more milk per cow. They had higher fat, so this is above 4%, but we're Jersey and Holstein here, and nearly 0.2% difference in protein, higher for the de novo, both on fat and protein, and more milk per cow. MUN was the same between the two groups, and a reasonable level of MUN. Northeast in 2014, the month we did this, given the fat and protein price, at 25 kilograms per cow per day average for 100 cows, this would result in a gross income difference at the ends of the scale of nearly $30,000 more for the higher components per 100 cows. That was April 2014. We went on in 2015 to look at the Holsteins only, and just like 2015, the milk price situation was quite different, and we'll see the impact of that. Low fatty acids, well, our high de novo group was higher in de novos. That's how we chose the farms, so that's not a big surprise. All Holsteins, so the kilograms per cow per day is higher now than it was in the previous study. No difference between the high de novo on the left and low de novo on the right, but the high de novo herds, 0.2% higher in fat, 0.1 higher in protein, MUN, no difference, reasonable MUN. So 2015, the protein price had gone down a lot per pound of protein. Fat had gone up a little bit, but we're still looking at nearly $15,000 a year per 100 cows at this level of production. So understanding how to influence these components and get them up while not losing milk volume really is something in terms of trying to push better profitability on farms. So this was our first look at what was going on, and it really wasn't just a concentration issue. This was really, they were producing more output of components per cow per day. So how did this happen? What did we observe on the farm that related to this? So less feed bunk space per cow. If they were more crowded, they were going to be lower de novo fatty acids, lower fat and protein tests. Showed up very clearly in both years, in both studies, that this was significant. And this probably relates to feeding behavior, slug feeding, rumen pH variation through the 24-hour period will have low rumen pH will have a negative impact on de novo fatty acids and milk fat. Higher stall stocking density, the low de novo farms didn't have as much resting space per cow. Again, we saw that as a significant effect. One of the things that we haven't drilled down deeper to yet is that in general on the low de novo herds, the ether extract in their TMR was a little higher. Neither the high or the low was, off the chart in terms of fat level or ether extract, but it was very consistent that the fat level in the diet was a bit higher on the low de novo herds. In the second year, the Holstein, we added PENDF measurement, effective fiber, and in general, the high de novo herds were up at about 26 to 27 on average, lower PENDF in the low de novo, lower fat herds. So the formulation also and fiber is something important too in what we observed in the field. So this is kind of where we got to on the observations and some of the things in terms of management. We kind of distill all this data and bring it together. This is from the 40 Holstein farms, and start to make graphs of de novo fatty acids, grams per 100 grams of milk, and bulk tank fat test. We see that if you're a Holstein farm and you want the 375 fat or higher, then the de novo fatty acids, there's some scatter, but R squared's 0.8. This is pretty good for field data, that above 0.85 is where you need to be to get that bulk tank test above 375. This is on the de novo. The mixed, which the plus the palmitic acid, the C16, when we add the two of those together, one of the things you'll note if we look back, there's a 8 R squared in terms of how well the relationship, how strong it is. When we added the mixed in, the relationship is stronger, and I think we have kind of a benchmark. Want to hit a 375 fat test, the sum of the two, the de novo plus the mix, needs to hit 225 or higher. And this is not some concocted, university herd study. This is field data from real farms in the Northeast. So this kind of says we need to pay attention to these two values and figure out what we're doing when they're higher than 2.25 and do more of that to keep these cows productive. This is on the preformed. So now this is the 18 carbon and longer, does not include the palm, the mixed. And basically the variation in that from all the field data, really not much of a relationship at all. The R squared is low, and this is not what's fueling the variation in fat test. There's another metric I mentioned. It's called grams per fatty acid, and this is an index of unsaturation. And this is not a driver. This is kind of an outcome that when de novo goes down, this number is going to go up. But there's an interesting relationship here. In general, so double bonds per fatty acid, that triglyceride that I showed you early on with 3 fatty acids, So what does this number mean, this 0.31, 0.32? That triglyceride has 3 fatty acids. This is kind of like census data. The average family has 1.4 children. What's a 0.4 child? What's a 0.3 double bond? That if those 3 fatty acids on the triglycerides, if one of them has a full double bond and the other 2 have nothing, it's 0.33. So that's how the number comes about. What we've seen in the field, particularly once you go on Holstein herds, now this is for Holsteins, it's different for Jerseys. On Holsteins, once you go above that 0.31, what we're finding is we do gas chromatography work to measure the trans 10 fatty acid in the milk in all these, that if you're above 0.31, the probability that you're going to have a high trans 10 and that you've got trans fatty acid driven milk fat depression is very high on this side, and it's very low on this side of the 0.31. So it's kind of a thing that says if this number is up high, I need to get a cross check, and if it's trans fatty acids, I got to figure out what's going wrong in the ration that's causing that milk fat depression to occur. One is an interesting one. This is the protein test. Here, novo, with something that was an after the fact thought that I said one time, so de novo fatty acids, is there any relationship to protein test? And it's interesting at that 0.85, if I move the de novos up, in general, the R squared isn't as strong as the fat, but the protein is higher. What's interesting, I've got 60 herds at St. Albans that were tracking this across time every month. There's not a single herd with a negative slope to this relationship. So moving de novo fatty acids up in terms of feeding and management will also do good things for protein. Why is that happening? So if we have a high de novo fatty acid level in the milk, it tells me that rumen fermentation is working really well. We're getting a lot of VFA production, but most importantly, we're getting a good, healthy biomass, the microbial biomass that's being produced in the rumen, the amount of it, and that contains a lot of essential amino acids. And those microbes go down the digestive system, they're going to be digested, and those essential amino acids will contribute in terms of substrate for synthesis of milk protein. So that's what we understand at this point we think is going on with the protein side. So we're up to another poll question for Mike. Back in.
Yes, we're ready to go, David. Here we are. Get ready to vote. Here's your question. Is there any relationship between the seasonality of bulk tank fat and protein test and milk fatty acid composition? We have 3 choices. Now we've increased your choices up to 3. First choice is milk fat and protein go up and down with de novo fat synthesis. Second one, milk fat and protein go up and down with preformed fatty acids. The third one, fatty acid group variation is not related to bulk tank fat and protein. Well, Steve, this is a tough one. Are you ready to vote, or are you going to make comments?
Well, I don't know. This is a little complicated for me, but I might go with the first choice.
Okay.
That's where we're heading with this discussion, but we'll see. Time will tell.
All right. We've
and votes are coming in pretty brisk. We're a little over halfway voted.
Yep, we're going to make sure that Dr. Barbino has enough time to let's close her off. We got 2/3, Jim. Let's close it off. And Dr. Barbino, what's your take?
Milk fat and protein go up and down with the. I think I'm going to show you some data that it really surprised me when we got the first data out of the St. Albans co-op at the relationships that we saw and how much this was in lockstep as we went along. So as we move forward, we're going to look at the seasonality. And this is Group 40 Farms at St. Albans. This is the bulk tank fat test. And the red is the de novo. And this is from January 2014 through April of 2017. And we were actually quite surprised at how this lines up so well, that bulk tank fat test, the seasonal variation that we see, it's really the de novo that's going up and down, and the mix, so the portion of the mix that comes from de novo synthesis, that the two of them together seems to be driving this seasonality. And if we can figure out how to make those fatty acids and the synthesis of those less seasonal, I think we want to stay up at the top in terms of fat level and not have all these bottom outs in the summertime. So this was the fat, and we go over the protein, a little bit out of phase, but boy, the same story here, that if you follow that de novo, and if you do de novo and mixed, it's going to follow the same trend. If we put a graph up here with the preformed, it wouldn't show any relationship at all to this. So it's really coming back to saying all this stuff that we've dealt with in terms of seasonality, and I see it in the manufacturing plants. Boy, you hate making cheese in the summertime because the yields are going to be low. You guys got the fat and protein low. I can't get efficiency out of my cheese vats. I'm starting to understand why it's happening. The question is, can we feed these cows, manage these cows to take the bottoms out of these gullies here and keep us up at higher protein, higher fat all year long? So I think this really tells us that we're on the trail here of trying to figure out how to mitigate some of the seasonality in the way we feed and manage cows. One of the things I want to bring back to is that we talk about seasonality and the effect of temperature. The more I've been looking at this, and we talk about heat stress for animals and all this, I wouldn't ignore the possibility that the heat stress is as much on the feed as it is on the animals. And we're starting to see this in terms of the effect of elevated temperatures on the way fat releases from fat-containing components in the diet, particularly silage, when it's exposed to higher temperatures. Stage of lactation impact has to be factored into this, but when you look at those farms where we had the seasonality, those aren't real seasonal herds in terms of lactation. They're pretty even milk across the year. But if you take groups of cows, different feeding groups, and do this testing, be careful, because there's big stage of lactation impacts that are normal for fatty acid composition variation. And here, this is some relatively new data out of the herd up there at Minor Institute. We've got week of lactation. These are lactation curves now for fat, protein, and lactose. So lactose starts out a little lower, but it stays pretty constant through lactation. Fat content takes the big drop here as milk production increases per cow per day. We're coming down. Same thing on protein. And then we make the steady climb, and this is the thing we'd be used to seeing. If we look at pounds, so pounds of fat, pounds of protein, we reach a peak, and then gradually we're going down. Lactose is constant, right? Well, this one, you start looking at lactose and say, wow, so she's producing a lot more lactose. That drives milk, right? Yep, okay. And then she starts down, and I kind of look at this, and we're going all the way from 5.4 pounds of lactose per cow per day down to 3.5. Boy, that's a lot of glucose. And understanding more about this, what we'd like to do is keep this output higher. And if we do that, we'll keep the output in grams per day higher of fat and protein too. So the more I'm watching this, the more I'm getting interested in what's going on with glucose as it relates to lactose synthesis. Come to the next slide. So this is a herd averaging 90 to 95 pounds of milk per cow per day. It's a TMR type of feeding. And here we have the grid. This is concentration milk. So this is where that 0.85 we want to be above to get a 375 or higher in the bulk tank. You see we're up there, 0.85, 0.9, doing pretty good in this herd. But the thing to notice is with days in milk, so this is lactation curve, the preform starts really high and it comes down rapidly. This is the mobilization of body fat, particularly on our multi-paris cows. Here, if we look, this is grams per cow per day and week lactation. And we see that de novo fatty acid output comes up as the cow comes up to peak, and then it's going to gradually taper off. We see the mixed coming up, but the preformed is coming from 950 grams down to 600. So a lot of that decrease, that's going to be 18 carbon, but we've got the C16 is coming up, and that's the mixed. So my take on this is the de novo portion of the palmitic acid is really pushing up now. Maybe you can do some feeding and bypass feeding to boost it even higher. But the two of these, the de novo and the mixed, are what are going to drive and sustain your output of fat through the lactation once we're in positive energy balance. This note of caution, that double bonds per fatty acid. So this is double bonds per fatty acid is the blue line, and preformed fatty acids, grams per 100 grams of milk, in the red line, and they match up almost perfectly. So we said above 0.31, be worried about milk fat depression. If we are kind of in a normal lactation curve, this number is going to come down in this range of 0.26, 0.28, 0.29. If I got a bulk tank that I'm getting readings of 0.36 at an average of 180 days in milk, there's something wrong. And that's where I find that metric useful as kind of a wake-up call, that if that number is really high, something's not right here in terms of the way milk fat is being produced. And when that number's high, usually the bulk tank fat test is low, and that's where we need to look for a cause. So if you are sampling groups of cows, and we got a group of cows averaging 20 days in milk, well, they're going to have a high preformed and they're going to have a high double bonds per fatty acid. That's normal for that group. They shouldn't be up above 0.4, but they will be higher than the 0.28, 0.29 level that we need to settle into at. From 167 farms across the U.S., the real question most of my friends were asking, particularly from outside the Northeast, well, you know, you guys, if you learn how to feed the cows in the Northeast, you'd probably be in good shape, right, Mike? So does this apply across the United States? So we went out last year, and here's de novo fatty acids and bulk tank fat test over all. There were 3 farms from Mexico that snuck into this. We had them in Western Canada, and generally our squared's a little lower, but as de novo goes up, bulk tank test goes up, and if we look at 0.85, about 3.7 plus, it looks like the same relationship, a little bit more scatter, but farms from all over the United States, the relationships we've seen in the Northeast seem to be valid. If we look at the de novo plus mixed, and our squared's better than just the de novo alone, and at about 225, we're right in there at about 3.7 to 3.8 fat. So this relationship across a wide range of management, feeds, everything seems to be holding across North America. Pounds of milk per day on these 167 farms. And the first thing I'd like you to note is we got all the way from 55-pound herds up to 100-plus pound herds. So this is a wide range of management and productivity. But grams per fat per day, really, if you want to get up in that 1,500 to 1,800 grams of fat output per day, you're going to need to be up here in the high volume production, R squared 0.75. What is interesting to me is this is what we see in fat in terms of the relationship with volume. So what does it look like with protein? The R squared is much higher. So really, as we've always known, a benefit, get production per cow up in terms of volume, and it's going to carry with it more output in grams per day of protein. R squared 0.92. We need to understand, you know, and really manage energy to get output per cow per day of milk up. So this is protein, something probably nobody ever looks at, because it's constant, right? This is grams of lactose per cow per day output, and this is pounds of milk. R squared 0.99. So if I want to be up in that range of 90 plus pounds of milk, these cows are going to have to make 1,800 to 2,000 grams of lactose per day to do that. These are Holstein farms. And that takes a lot of glucose. So management of diet and the glucose availability needs to be there to support this level of production of lactose and drive total milk production. The lactose grams per cow per day, when milk production is low, synthesis of lactose is low. Maybe the glucose is there, but maybe there's some other issues. We have a 3X multiparous cow that's going to produce over 85 pounds of milk, and she's going to need to produce at least 1,800 grams of lactose on an anhydrous basis. And that's really the foundation to build upon to get high protein and fat output if you manage the rumen fermentation right to get the VFAs to support and maintain the level of substrate for fat production and produce the biomass, microbial biomass to support proteins. So, achieve high output of lactose per day, glucose supply, transport, metabolism needs to be working well, need to have a high energy intake. What's going to modify that? When milk production per cow is low, there may be some cow health issue. So anything that's going to activate the immune system is all of a sudden going to put a demand on the glucose supply. So mastitis, lameness, leaky gut, any of these things, heat stress. As soon as you put a demand on the glucose supply, it's taking it away and you can't produce lactose. You don't have enough there. There's other hormonal things going on. It's all kind of integrated together, but you got to be able to produce lactose to get that milk output. So fermentation of forage is needed, good output of fat and protein, level of de novo fatty acids. Milk indicates that rumen fermentation is working very well, and there's high levels of acetate, propionate, and butyrate being produced, and that's important. And we're getting excellent fermentation of forage and producing a large biomass that provides essential amino acids. Fatty acid measurement, we feel, is an excellent tool to evaluate the effectiveness of rumen fermentation and forage digestion. Conclusions: the seasonality and fat and protein content of bulk tank milk is related to the seasonality and de novo fatty acid levels. Lactation has a large and systematic impact, as we'd expect, due to the mobilization of fat during the transition period. And what we've seen in the Northeast for the last 3 or 4 years really seems to hold up across a wide range of management conditions, feeding, everything across the United States. So these are pretty strong and fundamental relationships that I think for going forward, we can use this analytical data to really better understand what's happening in terms of those cows. Directions. We can talk about it. We can measure or estimate blood NEFA without taking a blood sample. We do it on the milk, and we estimate blood NEFA. This is handy on transition cows, but it's interesting when you have this on milk and can just run it any time, you don't have to take a blood sample, find a cow, get a blood sample, send off a sample to a vet school. When you can get it right from the milk right away, all of a sudden we're seeing that whenever that blood NEFA goes up past the transition period on an individual cow, she's telling us something's wrong. And I think that's going to be a useful diagnostic tool if we can integrate this into the milking system. We already have them on. We're working on a blood BHB. We're headed towards trying to do things where we could get some indices of stress compounds and inflammation. Can use a lot of uses for this information. And one of the things that we're questioning right now is whether we can actually, from the milk, predict what's happening to rumen pH. I'd love to have an 18-1 trans 10 fatty acid model. We're working on it. Not there yet, but maybe we'll get there sometime in the future. So the whole to do this kind of work, and folks at St. Albans Co-op have been great. The group at Minor Institute and all the folks there, Delta Instruments, manufacturer of the equipment's been extremely supportive and helped us in this. And the United States Department of Agriculture, Federal Milk Markets, really has been kind of the ground floor support on this. Their goal is to improve the accuracy of milk fat payment testing, but at the same time, the way we're getting there is to understand the fatty acid composition variation. And that kind of wraps it up.
Okay, very good, Dave. Thank you so much. Fascinating discussion. It gives us some real insight as to how some new technology that's available is helping us understand what's going on inside our cows. And it kind of whets our appetite for more cow-side technology that's around the corner. And gosh, some of the possibilities seem almost unlimited. So thank you very much for an interesting and very informative presentation. We also want to take this opportunity to thank QLF for their support of the webinar today. And now let's look ahead for the next webinars we have on our schedule. Monday, December 11, troubleshooting mastitis and milk quality issues is going to be presented by another Cornell faculty member, Dr. Paul Verkler from the veterinary school there, sponsorship there with Acumen Detection, a SRC company. And also looking ahead just a little bit further, something different in our webinar series, January 8th, how they achieve 40,000 pounds of milk per cow. Tom Kestel, Wisconsin dairy producer, a well-known and well-respected Holstein breeder, and his nutritionist, Steve Woodford, will be sharing the spotlight that day. And it promises to be a pretty interesting discussion as well. Just a note that this webinar and all of our previous webinars are available on the webinar archives that you can find by going to horge.com and following the prompts there. Also, you'll be receiving a very brief survey questionnaire by email here in the next couple of days, and we would appreciate your response to that as well. With those comments, I want to thank Dave again, David Barbano, and also always thank our cohorts, Mike Hutchins and Jim Baldstein at the University of Illinois for their help and support with this series. And now, are there questions, Mike?
Yes, there are, Steve. In fact, Dave is going to click right on, and we've got 3 of them posted. So, Dave, we got a question here from Lisa, and she says, what impact does dietary forage levels have on milk fatty acid analysis and or fat production? So you may have touched on that, but how will you answer her question?
Okay. In terms of forage levels, I think there's an optimum. And you get too little or too much, and you're going to have issues in terms of not having enough energy density in the diet versus not having enough forage to get the proper rumination and function of the rumen. But really, in the end, what you want to do is convert that forage to acetate and butyrate in terms of the fermentation. And as we can see from the fatty acids and the relationship of that, that acetate and butyrate production in the rumen is really pretty important. So dietary forage is pretty critical in terms of being able to support de novo fatty acid production and milk fat production. So I think that's forage is key, and quality of it is really important.
Okay, David, let's move on to your second question that was sent in before the conference call started here, and it comes from Wisconsin. Does TMR sorting have an impact on milk fatty acid analysis and or milk fat production?
Well, the short answer is yes. The question is whether you're eating the stuff before, at the beginning of the sorting and the end of sorting in terms of the individual cow. But I think it's more fundamental than this, that I kind of look at this from the distance, not being an animal scientist, and saying, it's kind of like making cheese. That rumen is a fermentation, and that's got to happen properly. And if anything, whether it's sorting, whether it's the amount of available starch, whether it's the way the cows eat in terms of slug feeding, anything that causes that rumen pH to go down and stay down for periods of time is going to have a negative impact on de novo fatty acid synthesis, negative impact on the rumen fermentation in terms of shifting the microflora, and that will translate to a negative impact on milk fat production. So sorting is just one of the ways that can have an impact, and it's really kind of getting at rumen pH and the proportion of fiber in that sorted feed.
Very good. Let's go to our last question that came in before the webinar started. And again, it comes from Wisconsin. What are the recommended dietary nutrient parameters to maximize fat production? Or how would you, as a scientist, maximize milk fat production?
In terms of the diet, I just am amazed. I make cheese and I get milk and it's white every day and it comes in and it's got a little protein fat difference. Boy, the selection of all the ingredients and everything you guys have is just mind-blowing. So I think the recommendation is you've got to meet sort of the nutrient requirements, but how you get there's a lot of different combinations that can do it. But in the end, you've got to have a diet that's not going to run that rumen pH down. You've got to have a diet that doesn't have too much unsaturated fat. So rueful level not being too high. But I think it's not just the rueful. If you take feed that has a high level corn silage, high moisture corn that has a high level of unsaturated fatty acids, and then there's some quality problem with it, like high moisture corn with a yeast fermentation, that yeast produces alcohol. The alcohol causes the fat to come out of the corn faster in the rumen. And all of a sudden at a rueful level that you thought was okay, you've been tipped into milk fat depression because there's too much unsaturated fat coming out of the feed too fast in that rumen. Same thing in terms of grind of soybeans. Grind them too fine and you're going to have fat coming out too fast and you're going to go into milk fat depression. So it's not only the diet, but the form of everything and how stuff releases in relation to rumen pH and available unsaturated fatty acids not being too high, and then keeping the energy density at a level that's going to support a high level of milk production per cow per day. I think those are the real kind of guidelines that you got to look at, and you can get to them by a whole combination of different types of feed materials.
Okay, David, we have a couple of questions that kind of relate to kind of a common theme. Have you tried to look at the impacts of the popular C16 saturated fatty acids versus the blends? Have you tried to tease that out of your data at all, looking at the source of preformed dietary fats that are rumen inert, supposedly?
Yeah, that's a really interesting question, and I think we've got to sharpen our knife here in terms of our fatty acid analysis. I know what you guys are after, and I think we really need to get down to being able to measure the palmitic acid and the stearic acid separately and get accurate test results would allow us to start parsing that out. I don't have any data on it at this point. but I think that's a direction we're going. And as we refine our analytical metrics, I think we may be able to answer some of those questions.
Very good, David. I bring you the next question as well. And that question has to do with pasture. Have you done any investigation with the effects of pasture on the de novo synthesis of fatty acids versus, say, TMRs?
Yeah, it's interesting. We've had some grazer herds, and actually this last year we did a study over in the Netherlands with grazers. And what is interesting is when they go out on pasture, basically the energy density, the ration and dry matter intake is kind of going down and production levels lower. You can get a fairly good level of de novo fatty acids as a proportion, but your output isn't real strong. And one of the things that was interesting, and this was just an aside, that blood NEFA test is something we're working with on individual animals. When cows go out on pasture, if they go out and eat pasture and you bring them in, you want them to eat TMR, and they aren't interested, their blood NEFA is going to go sky high. And we saw this over in the Netherlands, and everybody was in shock to see non-transition cows with such high blood NEFA levels. And it's because they were fasting. And so it's an interesting thing. I think we're going to learn a lot on grazing herds of how to balance and supplement the pasture to get the maximum output and production of the animals, given the fact that we're using a grazing approach. So I think there's a lot of stuff to learn on that, and these metrics will help us out.
Fairly technical question, David. Got your ears on here, and here it goes. I'm going to shorten it down a little bit. A great question. Would grams of fatty acids groups per gram of milk fat be more representative and sensitive of measurement of differences of cows and herds and its impact on milk production? A different way of analyzing it versus the looking at grams per gram of milk or something like that. Do you understand the question?
Yes, I understand it very well. That's where we started out. And actually, we found that it really was very difficult to troubleshoot and understand what was going on when we looked at grams per 100 grams of fatty acids. That's the way as scientists, we're used to looking at it in terms of gas chromatography results. But in the end, that doesn't tell, I can have the same grams per 100 grams of fatty acids and be producing a low concentration of fat or a high concentration of fat in the milk. And in the end, the paycheck is the grams per 100 grams per cow per day output. And that's what we really need to achieve. So we started there, but we've switched over to the system of looking for concentration of milk, not per fatty acids.
The last question we'll do, and several questions you've answered. Actually, there's about 5 came in while you were lecturing, and you've answered them very nicely. What about the cost of the test, like the Minnesota DHIA? Is there a cost to do this test, or is it just having the right equipment in there? What's going to be the bottleneck, if anything, with this test? Okay,
so the bottleneck, if you've got the DHI labs, they don't usually get bulk tank milk. So this fits best in a payment testing lab right now if you want to do whole herd type of testing. I have developed these methods on the Delta equipment, so these run on a that type of infrared analyzer. The information is being published. Other companies can develop the same sort of techniques. There's some work in doing that. So as this kind of gets popular, I expect all the brands of instruments are going to figure out how to do this and do the testing. But right now, it's sort of limited to labs that have the Delta equipment. But I think that's going to change with time. So I think that's really the issue right now in terms of getting it done.
Well, Dr. Rabino, you did just a fantastic job, and we had several great comments from listeners that said you did very well as well. So, Steve, we'll turn it back to you and let you finish up here. And thanks very much, Dr. Rabino.
Well, thank you, Mike Hutchins. I certainly agree that it was an excellent presentation, Dave. Very nicely done, and good job with the questions as well. Lots of interest. We had a nice big audience out there with us today. So thank you again for a great job. I'll be confirming your participation by letter here in a couple of days. And lastly, we want to thank QLF for their sponsorship. And just reminding, we're going to be talking about mastitis on December 11th. Dr. Paul Verkler, Acumen Company, is going to be sponsoring that. And we're going to be looking at how to feed and manage for 40,000 pounds of milk. Tom Castello, Wisconsin dairy producer, and Steve Woodford, his nutritionist, will be with us on January 8th. And with that, this is Steve Larson from Hordes Dairyman signing off up here at Fort Atkinson, Wisconsin. Thanks for being with us. We look forward to having you with us again.